Now let's get an introduction to the Solidity programming language. So Solidity is the primary language for writing Ethereum smart contracts and for other EVM compatible chains. And so definitely check out the video on smart contracts in the conceptual portion of this program if you want to get an overview of what smart contracts are and how they work. But in this video, we're going to get our hands dirty with the Solidity programming language. So I'm going to show you how to write your first lines of Solidity code. This is just going to be a primer, all in your browser, okay? But we're going to do this a lot more in depth in the Capstone project. We're going to dig into Solidity quite heavily, write a ton of Solidity code. But in this video, I just want to get your feet wet with it. And we're going to do everything, like I said, in your browser, so you don't have to install anything on your computer. You can write your first Solidity smart contracts in Remix, which is an online Solidity IDE where you can, write this code inside of here, deploy it to a test blockchain, and test it out. This is a great tool that I use all the time without having to install anything on my computer. But we're definitely going to configure our system in the Capstone section and go way more in depth. So let's start off with, the Solidity programming language. What is it? So it's the primary language for writing Ethereum smart contracts, and it's an object-oriented, high-level language that looks a lot like other programming languages like Python and JavaScript. It's a fairly beginner-friendly language, as are the other languages that it's highly influenced by. So that's really good for you if you're, a brand new developer or you're just trying to transition into blockchain. You can pick up Solidity pretty fast on the grand scheme of things. Now, don't let that confuse you. Solidity is also a very powerful programming language. It is called Turing complete. So that basically means it has all the features of a fully robust programming language. You can do most things in Solidity that you can do in other programming languages. And it runs on the Ethereum virtual machine, which we talked about in a previous video. It is also statically typed, all right? So you're going to see what that means if you don't understand that already whenever we start coding out our Solidity smart contracts. But if you are a programmer already and you understand that, that's important to note here. It supports inheritance, so you can make, sub-smart contracts, or children's smart contracts or child smart contracts that inherit from a parent, all right? It supports third-party libraries and all types of complex user-defined types, among many other features. The last thing I'll say here is that Solidity is object-oriented, which really means that the contracts themselves are, basic units that you can use to build more complex code bases. So you can have smart contracts that inherit from other smart contracts. That's like what we see here with inheritance. You can also have smart contracts that talk to other smart contracts, much like other classes and objects and object-oriented systems. And it's high level. That means you can accomplish most general tasks with the general Solidity programming language syntax, and you don't have to implement a bunch of low-level system processes that you might have to do really advanced in other languages. And that's another reason why it's pretty beginner-friendly. So now let's go ahead and create our first smart contract. So head on over to remix.ethereum.org, and you should see an interface that looks somewhat like this. Okay, this changes from time to time, but it should look mostly like what you see here. And let's just talk about what Remix is. So it is a browser-based text editor or IDE, but it's a lot more than that. So you can create smart contracts inside of here. You've got this file browser where you can create a new one. You can also compile smart contracts inside of here. So you can take the human readable code and turn it into machine readable code that the blockchain understands. You can also deploy it live to a blockchain. You can deploy it to a real public blockchain like the Ethereum mainnet, Ethereum test network, or you can run a basic blockchain in your browser without having to install anything on your computer, and basically, dream up a smart contract, code it out, test it out, all in your browser without having to install anything on your computer. That's the big benefit. That's what I use it for. Of course, I'd like to use advanced developer tools on my own system, but sometimes it's great to just sketch out a smart contract inside of Remix and save it for later use. So let's go ahead and do that. So you can go over here to the file browser. All right, make sure you go to this tab, and then click on this icon right here. So this is going to create a new file, and we can just call this my contract. So capital M, lowercase y, contract, capital C, contract.sol. So .sol is the file extension that we use for Solidity smart contracts. Okay, so I'm going to hit enter, and that's going to bring up a new page here. And this is where we can write our first line of Solidity code. So I'm going to increase the font here. I'm going to just click zoom. And the first thing you do every time you write a smart contract is declare the Solidity programming language. So I'm going to say pragma, okay, Solidity. And then I'm going to tell the version number. So I'm going to say 0.0 8.7. And then I'm going to end each line here with a semicolon and hit enter. And so this is an essential step that you have to do every time you create a smart contract, is tell it what programming language version you're using, because the compiler needs to understand this. All right. And so next, I'm going to declare the contract like this. We use the contract keyword, so contract, okay? And then you give it an arbitrary name. So in this case, I'm going to call it the same thing that we named our file here, so my contract. Make sure you capitalize the M and the C. And then we're going to do an open curly brace, and you can see the remix automatically closes the curly brace like this, so it'll keep your cursor inside of there, and you can enter. And then all of the code for the smart contract is going to go inside of here. Okay, so again, Solidity is an object-oriented language, so basically that means, everything inside this smart contract is treated kind of like a class, and you can reuse this in multiple places, and all the code for the smart contract that you might want to reuse needs to go inside of these curly braces. And I'll also mention while I'm here that you can see whenever I do a tab that it goes over 1, 2, 3, 4 spaces. That's because the convention for Solidity is to have 4 spaces every time you do a new line. That's opposed to maybe other programming languages where you might have 2 spaces. The convention for Solidity is to do 4. All right, so now let's talk about the smart contract that we're going to create here. So really, this is just supposed to be a primer to the Solidity programming language. So what we're going to do is kind of create a hello world contract that essentially just makes sure that we can create a smart contract that's some basic functionality and put it on the blockchain like a smoke test to ensure that it works. So what this smart contract is going to do is just store a single variable value on the blockchain itself. And then we're going to be able to retrieve the value of that variable and then also update it with a special function. Okay, so we'll just store a value on a blockchain and we'll update it and we'll read that value. So we first and foremost need a place to store that. We can do it with a variable like this. We can say string value. Okay, this is going to be the value that we update and read from the blockchain. So what did I do here? So you can see this keyword string space value. So what is that? Well, I've created a variable inside Solidity, a specific variable called a state variable. I'll explain that in a second. But you can see the string keyword here. Again, Solidity is a statically typed language. So what does that mean? Well, essentially it means that this variable named value here is going to be a string type. So what is a string? Well, a string is just, a collection of characters inside quotations. So like, my value, this is a string, it's an example, okay? And so that means that this variable called value can only ever be a string data type. It can't ever be something like, an array. It can't ever be something like this, 2, 3. It can't ever be, a mapping or anything like that. We'll get into all those data structures later in the Capstone project. But basically, this is always going to be a string, and we have to declare that whenever we declare the variable here. So value is literally just the name of the variable. It's an arbitrary name that I just picked at random here. But it's semantic, right? This is the value that we're updating and setting on the blockchain. Okay, so now let's talk about this as a state variable. So what does that mean? Well, again, we are going to update the value of this variable, and it's actually going to be stored on the blockchain itself. So that's what it means by state. Again, the blockchain is a big database, okay? Whenever you put these smart contracts on the database, you're creating programs that run on the blockchain, and you can update the blockchain's state with state variables. So whenever you see a variable inside the smart contract like this, and you update this, the value is going to be saved forever on the blockchain, okay? So let's create a way to access the value of this, okay? So we can go down here and create a function. So you create a function inside of Solidity like this. You say function, use the function keyword, and then you give it a name. So I'm going to call this function get, okay? And then I'm going to end it with curly braces and hit enter. And now I can write all the code that's going to get executed inside this function. So what am I going to do? Well, I'm really just going to get the value. So I'm just say return value. And whenever we call this function, it's going to take whatever the value is and return it outside the blockchain. So value is going to be stored on the blockchain. And if we want to access the value of value, then we call this get function, and it's going to read it from the blockchain and return it to our browser or wherever we're reading it from. So another really important thing to mention here is the scope of this variable. So variable scope just means where can you, read the value of this variable and where can you update the value of this variable. So state variables that are declared inside the smart contract up here like this, you can access inside of functions. And so that's why I can, return the value of value here as opposed to a local variable. And we'll see examples of that whenever we start coding out the capstone project. Also, you think about the state variable being stored to the blockchain. We're kind of treating the blockchain like a specific database. It is a database. And you might, if you come from another programming background, like an object-oriented background where you have something like an ORM, an object relational mapper, where you are taking a class or a function of some kind and you are mapping the values inside the class to database tables and columns. That's kind of like what you're doing right here. All right, so this get function is almost complete, but we need to do a few more things to it. So there's a problem with this. We can't actually call this function yet outside of the smart contract. Okay, so in order to do that, Solidity supports something called visibility. All right, so this is the function, and we need to tell Solidity that this is public. Okay, so this is the visibility, which basically means that whenever we're outside the smart contract, we can actually call this function and get the value back. All right, and there's one final thing that we need to do here, which is specify the return value, because Solidity wants to know what's going to be returned from this function, and we can do it like this. We can say returns, and then use parentheses here, and inside of here, say it's going to return a string from memory. Okay, so it needs to know that it's going to return this data type. Again, Solidity is statically typed, so it wants to know that it returns a string from memory. All right, and so now we need to do one more thing here, actually. We need to say public view. It's a view function. It's just going to return some information, okay? That helps us know that we're not going to modify anything inside the blockchain when we call this. All right, and so it's a read-only function, basically. So now what we want to do is actually create a way to set the value. Right now we can return it, but we have no way to actually write it, and it's basically nothing whenever we create the smart contract. So we'll create a new function like this, say function set, all right? And this is going to be a function that actually accepts a parameter or an argument. So we can add some parentheses here, and we can tell it what the argument is. We can say it's a string because we want to set this value. We want to pass in a string. And so I'm going to say string memory. We must tell it it's a memory and do underscore value. Value. And so this is going to be the variable we pass in. Okay. And we also want to tell Solidity this is public as well, so we can call it outside the smart contract. And then inside of here, what we're going to do is just take this value, okay, and we're going to assign this value here. So you can say value equals underscore value, and then end that with a semicolon. And also, I just realized that I made a typo here on line 6. So this should be function. I left out an N. So my syntax highlighting was telling me that. And also I had this, this warning here. Okay, so now that should be good. So I'm going to leave that mistake in the video because, hey, that's real world programming. And you can see my error caught there in real time. And so going back to this set function, okay, so what is this function going to do? Well, it's going to update this state variable's value. And so one thing you can notice here is we're passing in this variable here, and this is a local variable. So you can see I've used an underscore here. There's nothing magical about the Solidity programming language that says you have to use underscores for this. I just do it as a convention to differentiate between local variables and state variables, especially when they have the exact same name. So you can see a state variable here has value with no underscore. Well, we want to differentiate between this value and this value because they have the same name. But also, again, this is a local variable, so it's only going to have scope inside this function. You couldn't read this value like up in here, but this has scope within the entire smart contract, so we can access it here, we can access it here, we can access it here, and now we set it like this. So let's go ahead and compile and run this so that you can see how it works, so that we can actually set the value and fetch it back out. So I've got some warnings here. I'm not sure if they're actually correct. Sometimes Remix gets a little buggy, but let's just see if it actually works. So let's go to the compile tab. Now you can see this here. And what we're going to do is select the Solidity programming language version. So 0.8.7 is what we want. If you're using a different one, then you might want to choose yours from the list here, but definitely use this unless you have a good reason to do otherwise. We'll say click compile, and let's see if it works. All right, it did. So my errors went away. I think there's just a bug inside of the editor there. So you can see a warning down here. It's asking for the SPDX license identifier. You can ignore that. We don't need to add that for just testing purposes. So we compiled it, which basically takes the human readable code and converts it into machine readable byte code And it also just makes sure that there's no errors in the code. So if it passes compilation, there's no basic syntax errors inside the source code, which is a great step. So now we can deploy it to our blockchain. So we can go down here and you can see this environment. You can change environments up here, but for now, let's just leave it on this. So basically, we have a blockchain running in our browser, and you can see multiple accounts in here with 100 fake ether. So we don't need to connect a wallet with MetaMask or anything like that. We can do everything in our browser really nicely because, hey, we've got a full-fledged environment inside of here. If you wanted to deploy this to a test network or the mainnet, you could just switch to your MetaMask wallet here and then, connect your wallet to a different network to deploy that way. But for now, we're just going to do it in our browser. So let's select our contract, which is my contract here. We'll click this deploy button. All right. And I'm going to pull up my browser here, and you can see that here's the transaction, and it was deployed. So now you can see this drop down here. It says my contract. You can see the address. You can copy it if you want to. But now you can see these two buttons. So for set and for get. All right. And these correspond to the two functions that we created. Set, is here, and then get is here. And so you can see that the write functions, okay, are orange, and the read functions are blue. So we can just click on get, and it's going to return the current value of the state variable value. All right, because that's our get function. That's what it does. And right now it's empty because we haven't set anything yet. And we can set it like this. We can just say, hello world. All right, click set, and it will transact, and you can see the transaction receipt here. And then we can click on get, and then boom, there you go. Hello world. It returned the value like we expect. All right, so now let's continue changing this smart contract. So what I'm going to do is actually modify the smart contract's source code. All right, and so what's important to understand is, again, smart contracts in and of themselves, you can't change the code. So whenever you are going to change the code in development, you have to deploy a new copy of the smart contract. But that's what's really nice in Remix is you can, just deploy multiple versions without, many changes. So what I'm going to do is go inside the smart contract and create a default value for this value. Because when we tested it over here, we deployed it, it was empty for the first time. And we don't want it to be empty when we put it on the blockchain. We want it to have a default value. So there's a few ways you could do this. You could just inline, set it equal to, hello world. Okay. But I'm not going to do that. Well, actually, let's just do it. Let's just demonstrate it. Okay. So let's just do it and then compile. You can see how easy it is. You can just compile and then deploy. All right. You can see a new copy of the smart contract is created down here, and you can click the get value, and it says hello world. Okay. So I'll show you another strategy, which we can set this value inside the constructor function. So what is that? Well, the constructor function is a special function that gets run once and only once whenever the contract is deployed to the blockchain or when the contract is created for the very first time. So you can create a constructor function like this, use the constructor keyword, you say constructor, all right? And then you do open and close parentheses like this. If you have any arguments, you can put them inside of there, but we don't. So I'm just going to do curly braces like this. And inside of here, what we're going to do is simply set the value like this. We just say value equals hello world. Okay. And then I'm going to go through the process of compiling that one more time. Okay, so now it's telling me that we have an issue here. So what did we do? Oh, we forgot our semicolon. That's why you do the compile step. All right, click compile. All right, now it works. And we can go to the deployment tab, and I'm going to exit out of these other smart contracts so it's not so messy in here. Click deploy again, and there we go. It worked. So now we can get the value. It is hello world, and we can update it like this. Say, foobar or something like that. Click set, and then get, and there we go. It works. All right, so that's an overview of the Solidity programming language and a quick introduction on how you can create smart contracts quickly inside your web browser without having to install anything on your computer with Remix. So again, this is a tool that I really like to use for just sketching out smart contract ideas, but we're going to deep dive into Solidity heavily in the capstone section. And we're also going to configure our system with command line tools and frameworks so that we can create really robust smart contracts with tests. But But I just want to give you a quick introduction to the programming language, a primer, and introduce you to this tool that you can use for other purposes, because I do too. So that's all I got for this video, and I'll catch you in the next one.